I will introduce you to Alvaro de Pascual Colar. Whenever you want, the floor is yours. We'll start with the first tutorial.
Hi, good morning to everyone. Well, today we have two tutorials in Jupyter Hub. The first one is a basic tutorial on how to have some use of the data of Copernicus Services. We have focused this visualization in the theme of assessing ecosystem health, but at the end it's quite standard tutorial about visualization of data that can be applied to any data in Copernicus Services. And after that, we are going to do a tutorial on explaining how to compute marine heat waves using Copernicus Services data. To go to the Jupyter Hub, here in the Padlet you have this link, so you just have to follow this link. And well, as Andrea said, you will need an account in the Copernicus Services, and you can enter in this using your username and your password. Okay. And you will find this. You can see that in this screen you have split it into two areas. There are the two areas. In the left panel you have a file browser that usually starts here in your home directory. Here I have some files. Any user probably will have different files here, but everyone should have this folder, shared notebooks. This folder is quite important now. And in the right panel, sorry, we have this. This is a workspace where we can see launchers to launch notebooks, which is the main tool we are going to use today. We will see later how it works. And there is also interesting this icon, which is a terminal. We can click here and we enter into a Linux terminal. So we can work here like in a Linux machine, right? So as in every Linux machine, we can hit a double. So we can see the files that are in our home directory, right? They are the same files that appear here in the file browser. Well, it's interesting to know that what have to do to start working. The first thing we have to do is to get the course and to copy the course into our home directory. So as I said before, there is here a folder, shared notebooks. You can follow this folder, and you will see that there is a list of courses that you can download any course and you can follow any course here. Today's course is this one, the Training Assessing Ecosystem Health 2023. So, but you can enter in this course and you can see whatever the things that are associated to this course. But it's important to know that you cannot run the courses in this directory because shared notebooks is a directory, it's just an storage directory, and you don't have permissions to write in this directory, so you cannot make changes to it. So the first we have to do is to copy this directory to our home directory, and then we can start to work in our own copy of the course, right? So, well, to do this, we are going to use a Linux command. Probably people familiar with Linux will know. So in Linux, to copy a directory is we use this command copy -r because it is a directory and we want to do it recursively. And here we need the path of the directory we want to copy. So to find this directory, we can go over here and with right click, there is here an option that copy path. And with Control V, we can copy the path of the directory we want to copy. And the last argument in this command is the location where we want to copy the directory. So in Linux we use dot to refer to the directory where we are already are. Well, we hit enter, and this can take some time, maybe a few seconds or maybe a minute. During this time, we can go back to our home directory here, and you will see that during the copy, you are starting to have this directory, which is the directory you are copying. Oh, I think this is taking a little bit more time than usual, maybe because there are lots of users right now. Oh, okay. It has finished, and while when the copy is finished, you can close this window because we have our directory copied here in our home directory. And well, we can start to work properly in what we want to do. We can close this window right now, and you will see that in the directory of the training course, you will find two different Jupyter notebooks files. The first and the second one. The first one is the basic tutorial. We are going to start with this tutorial right now. So you can open this tutorial, and you will see that it opens in a new window here. I don't know if you are familiar with this kind of tutorials or with this kind of documents. A Jupyter notebook document is a document that mixes some documentation, like you can see here. For example, we have a lot of text explaining things, and it also mixes cells with code. To run these cells with code, as you can see here, you can click on the cell and click the run button here, for example, and you will see here the process of running. When we click in run, there is here an asterisk, and when it finishes the running, appears a number. So while there is an asterisk, the cell is running, and when it finishes, there is here the ID of the command you sent, right? Well, we'll see about this later, about this code. I just wanted to introduce this tutorial, talking about, well, what means assessing ecosystem health. And most important is what can provide Copernicus Services to help in assessing ecosystem health, right? Well, as probably most of you will know, there is many models that allows to evaluate the health of an ecosystem. And these models always work with a lot of variables because the health of an ecosystem is sometimes threatened not only for biological variables, they are also threatened by physical variables, and very usually for social variables. So the models, the models usually, the current models used to evaluate the health of an ecosystem uses 5, for example, in this model, 5 pressure, state, impact, and response model, use different groups of variables to evaluate the state of a system. As you can see in the layers of the state, and well, the Copernicus Services can provide not data, not in every layer, but yeah, it can provide lots of data, especially in the layers of the state, to define the state of the ecosystem and also to evaluate the impact of the changes we made, right? To evaluate the state of the ecosystem, we can provide lots of variables, like variables about acidification, nutrients, turbidity, tidal range, because sometimes it is also important for for the health of an ecosystem, temperature and salinity, because they can also have a role in the health of an ecosystem. There is also variables about dissolved organic carbon, pH, etc. Also distance about of ice to the coast, etc. Right. Well, in this case, we are going to download data of probably a very important model. In this case, we are going to download data from the global biological geochemical model. And we are going to see what this model can provide, what variables can provide, and we are going to see some visualization of the variables. And to do that, well, the people which is familiar with Python code probably will know that in Python, first thing we usually do is to launch the libraries we are going to use in our code, right? So this is the first setup of our system. Here you can see we are going to use different Python libraries. For example, these warnings is not an important, it's just to avoid warnings. But the important ones are this NumPy and XRI, which are libraries for numerical computation. In the case of NumPy and XRI, it's very useful in our case to open netcdf data files. You will see that in Copernicus, every data file is stored in netcdf format. So this library is very useful. And we also use different functions from matplotlib, which is a Python library, very famous library used to make plots, scientific plots. And also we are going to use Cartopy, which is a library that is oriented to help making plots, but not flat plots, to project plots over maps. So you can include coastlines, you can shade the terrain, or you can use different projections like Mercator projection or cylindrical, etc., conical, etc. Right? But we are going to use Cartopy. Well, and the first we have to do to start working, obviously, is to go to the Copernicus Services and to go to the Copernicus Marine Data Store and download some data, right? Because we need data to work. Well, in this case, here in this table, I introduce the information you need to download your own data. First of all, I will say that in this case, we have a directory here, data, where it is included every data it's needed for the tutorial. So you don't need to do this step. Yeah, I think it's very interesting because it's an important step that you will have to follow if you want to do your own study, right? So, for example, here I give you the information you need for this first tutorial. You will need to download the data from this product that you probably know. The Copernicus product, every Copernicus product has an ID code. This is the code we are going to use. You can follow this link. And you will go to the Copernicus Data Store webpage where you can see the product, where you can see the product. You will see that the product has its own product ID. And when you go to the downloading page, you will see that every product also has a list of data sets. These data sets are usually related with the frequency of the data you are downloading. For example, in this case, in the case of the data of the global model, biogeochemical, there are two data sets. One of them is the daily data, and the other one is monthly data. In this case, we are going to use this multi-data, and in this web page, you can download whatever you need. For example, you want to download multi-data for excluding some variables like this, and also you can select a window to download a specific region in the world, and you can select the specific dates and a range of depths, right? Then you can click here to download, but it is very interesting also this button at the request. We will see later what this means, and you will find this instruction, which is quite astonishing, but it's very useful. We will see later. Well, so with this information, you can go to the web page, to the data store, and download the data you need. But as I said before, we already have the data, but you can also use the Motu client. The Motu client is a system that allows you to download data, not using the web page, but using an instruction, a very long instruction, like you can see here. It is really, really long. But in this instruction, you are requesting through Motu client some request of data, some data. So in these instructions, you have to define the service ID, as I said before, the ID of the product you want to download. You need also the data set. You need also information of the range of dates you want to download. And also, for example, information of depths you want to download, variables. If you want some different variables, you can make a list like this, for example. And well, at the end, there is also two parameters, the output dir, and also the output name of the file. And these ones are very important because you have to include here your username and your password, obviously, because you are accessing the Copernicus Services data store. So you need to access with your user and your password. So you have to change here your user or your password. Well, I don't spend more time on this, but I just want to show you how works this. For example, downloading this here, we are downloading two different files. For example, this one, Python, this one, and there is another instruction because later we will need a different file. So I just want to show you how can it work, but since I don't want to share my username and my password, my Copernicus password, I am going to use this trick just to hide my user and my password. And well, you can run this cell, and probably you will see that you sent a request to the Copernicus Services, and this can take maybe 1 minute or two in downloading the data. But well, you have this is because when you are doing a request to the services, you are requesting a specific period of time, a specific window of data, specific variables, etc., etc. So the system has to find in a huge database, in the huge database of Copernicus Services, it has to find the data you need, and it has to create the file, format the file. Well, sometimes it doesn't take too much time. Right now, maybe, I don't know. Well, we can let it be for a few seconds. Maybe we will, okay. It starts when you In this period, the system is preparing the file you are requesting. Now, once the system finds the data, you start with the downloading, and you can see it downloads pretty well. Just a hint. What do you have to do to be able to use the Motu client in your system? I included here a link to the help page of Copernicus, to one help page of Copernicus, that I think it's very useful and very simple and go straight on. You just follow these instructions and you will be able to use the Motu client in your system. So you can use this kind of instructions in your system, and you can. This is very useful when you have to download data. Recursively, because once you have this instruction, that, as I said before, this instruction can be found here, because you have to select what you need and you get the instruction here. And once you have this instruction, you can start to play with it, changing, for example, the dates you want. So you can download different dates, different files with different dates, and you can start to play with the variables you download or the depths, etc. So you can split the downloading data of data, right? Well, so we already have all data, but what can we do with this data? Well, first of all, we have to open this data and get it accessible for the system. So in Python, we use to do that. We use, as I said before, the XRI library. It's a very useful library because any data downloaded through from Copernicus Services is stored in a PDF format. Probably for people who is not familiar with this data format, I will say that this format has three kind of objects inside a file. There you will find three types of objects: the variables, the dimensions, and the attributes. Let's say that variables are the arrays of the data itself. And these are the arrays you will need for this is the multi-dimensional arrays of your data. And also you will find the dimensions, which are some special one-dimensional variables that define the dimension of the different variables, and also attributes that are actually labels that maybe can provide information, but they are not very useful. We can run this cell to open a data set. Here you have a cell where we use the XRI library using the function open dataset, and we include after the as a parameter for the function the file name of the path and the file name of the file we want to open. And you can see that this will create a new variable, a new object that we have called DS, and here we are printing info for DS. So if we run this cell, we get this, which are when we print this, when we write this, we get a small report of the data stored in DS, and we get this. You can see here we have 4 dimensions, as I said before. The dimensions in this file are depth, latitude, longitude, and time. You can see also the length of every dimension. Depth only has one layer. Latitude, we have 600, more than 600 latitudes, values of latitude, more than 1,400 values of longitude, because we have downloaded the data for the world. And we also have 13 time steps. You can see here some more information about the variables. Here you can click and get some report, some information, and you can get the attributes of every variable. For example, in the dimension latitude, we have these labels that you can see. There is information like units and log names, etc. And well, we have the information of latitudes, longitudes, dimensions, and here we have all the variables we have downloaded. Here, I think it's the most interesting right now, because here we have a quite wide spectrum of different variables. For example, we have here information of partial pressure of CO2. For example, O2, oxygen, concentration of oxygen, chlorophyll, this is nitrate, phosphate, phytoplankton, total phytoplankton, silicium, pH, this is, excuse me, this is total alkalinity, net primary production, dissolved organic carbon, and iron, concentration of iron. You can see there is information of many nutrients like phosphate, nitrate, and iron, oxygen. So these are the kind of variables that Copernicus Services can provide most of time for assessing ecosystem health. Here we are focused in geochemical variables, but obviously the Copernicus Services also can provide physical variables like temperature, salinity, significant wave height, etc. Right? Well, we have our data. You can see here we are working with quite big array, 4-dimensional array. Well, since this is dimension 1, there is just 3-dimensional array, right? Actually, but we are working with an array of lots of values. Well, what can we do to access this data, right? The interesting thing is what we have the data here. The data file is open. So what are we gonna do? What can we do with this? Well, for example, I want to explain how to plot a simple map of one of these variables. In this case, I will plot, for example, here I am defining some simple variables, character that we will need to work. For example, we want to plot, for example, CHL, which is chlorophyll. This is the name that appears here in the report. So if we want to plot chlorophyll, we refer to chlorophyll like CHL variable. We are going to plot a map of one specific date, because to plot a map, we will need an array of 2-dimensional array, obviously, because to plot a map, you need 2 dimensions, latitude and longitude. So at the end, you need to select the data you want to plot, selecting what depth, which is only 1, and the specific time you need, right? So, for example, for this example, you can change this, and you can go and click modify this and see the results. I selected this date, February 2023. This is interesting to have it also. The name of the dimension latitude and the name of the dimension longitude. This information can be found here in the report we had when plotted DS, right? Well, with this, we are using a function from XArray, which is cell function, very important function about XArray, that will select the specific data we are asking here. For example, you can see here we are referring to DS with the name of the variable. So with this, we are selecting the data of DS of this variable, which in this case is chlorophyll. And from this data, we are going to select in the dimension time the specific date we want to plot, right? we are using the method nearest. That means that we are looking for the nearest date to this request. Well, this is just to remove any dimension with size equals to 1. Well, this is a technical thing that maybe doesn't matter right now. If we run this cell, we will get this. You can see here with this command. With this command, we are getting a new variable that is data to map, and we print data to map, and we get a variable with an array of two dimensions, latitude and longitude. Only one, these 2 dimensions. And well, I think there is not much to explain about this array, just that it has 2 dimensions, and we can go directly to plot this variable. How to do that? We have included this cell. Here you can see that we have defined a function that we have called plot map, and after defining the function, we use the function plot map. If you don't mind, I will run this function. You will see that this function right now takes quite a long time to run, so I will do it, and later we'll continue explaining this. The function is running, and you can see it takes quite a long time. Later we will talk about this. Explaining a little bit about the function we are using. This function defined. We have wanted to do this in this way because I think it's interesting for you. You can cut this function from here and put it in your own code, and you can still use this function for your own code, and it should work. So the using of functions inside Python I think is very interesting because you can make much more modular the code, and since you have this function here, you can cut this function, include it into your code, and it should work like it works here. Well, the function, you will see that there is 4 chapters. In the first thing we do in the function is to create a figure and an axis inside the figure. These are technical commands inside Python. And since we have defined the axis as with a graphical projection, we can start to work with, we can define the map features, like, for example, we want to draw the coastlines, we want to draw the latitude and longitude lines. The function has finished, right? We get this map. We will go over the map. Or some instructions, like if we want to mask the land, for example, etc. And here it is the instruction, the command to make the specific plot. To make the plot, we use this function from this is matplotlib. This is a picolor map, picolor plot, which means make a shade color, and we have to give it information of latitude, longitude, latitudes, and data. The specific data, would be the Z axis, and the color map we want to use. This is commented right now. We will go over there later. And here we include some editing commands. For example, the title of the title of the plot, and the color bar. We want to include a color bar, etc. The ticks, the size of the ticks, and the labels, etc. And when we run this, well, as you can see here, we have a map of the chlorophyll concentration all over the world. Well, this is quite much blue, right? This is there is 2 things here. The map is quite much blue, and also the function has took long time to RAM. Let's go over the second point. Why this took so much time? Well, it is because we are working with a very big array, so the system gets difficult on finding the memory, etc., to plot this map with so much information. How can we improve this? Well, so for example, as you can see here in this cell, I include two options that are not mandatory, but can we apply it? Option one allows you to subset a range of latitudes and longitudes in your map, so you can make a map in a specific location, for example, I don't know, in Japan or in Canada, whatever place over the world. I will let this option if you want to play with it. I think it's interesting, so you can see how it works. And we also have this option that I'm going to uncomment, that as you can see, we define a variable which is skip, and we use again over the variable data to map. We use again the cell function to sell a slice of latitudes and a slice of longitudes. But actually, we are not slicing the variables. We are using the slide procedure to skip some data. So with this, since these data are defined, the variable skip is defined as 4, we are selecting every fourth data in the array, right? So as you can please look at this, the latitudes are 600 and 1400. If we run this again, we obtain a new array. Data to map is a new array, but it has a lot less values, right? It's a smaller array. So if we go over the plotting cell, this takes a few seconds, but as you can see, the result goes a little bit clearly faster. Obviously, we have lost resolution in our map, but sometimes it's interesting because you don't need so much resolution for a map of this size, so you can find a compromise between the fast of the code and also the resolution you use and the size of your maps. And if you want to plot a very huge map with lots of information, it will take time, obviously. Well, we have solved one of the problems we found, which is the performance problem. But this map is still has a lot of blue. It's not very contrasted. So, well, what can we do here? We are using, you can see, we are using a linear color scale. And this is a little trick, very used, very normal. It is the using logarithmic normalization. This is the use of logarithmic color scale. It's very common to use this. So we can comment this line. And with this, we are defining that in our diagram, we want to use a logarithmic normalization. So our color scale will be a logarithmic color scale. We can run this right now. And you will see that, well, it is a lot more contrasted, right? So this kind of normalization is very, very, very common when you use biogeochemical variables. There are lots of variables that can be improved, the visualization using, as you can see here, we have a logarithmic color scale. Well, jumping to the next, just to would like to encourage you to try to do these exercises and explore everything. If you want to plot other variables like O2 of the phytoplankton, I think it's very interesting to play with this and see what can be done, or even you can also try to unlock this option and see what happens and play with it and try to plot a map of a specific region you're interested in. And well, we are now finishing the tutorial. The last step, it would be, well, we want this is very interesting. We have a world map of chlorophyll, but what about if we want to follow the time series of chlorophyll in a specific point? Well, we include this chapter here in the tutorial, where we are going to plot some time series of in this case, the variable we are going to plot is O2. I've selected this point in the wall. And as before, we are subsetting the nearest grid point. So we are going to use, as before, the data set, the variable in the data set, and we are going to select this variable, the latitudes near to that, and the longitudes near to long, using the method nearest, right? This will display the data selected. Well, this is only to show a map little bit. This is just to show a map of the location we have selected. And well, we can go over this cell that, as you can see, is a lot easier because it only creates a time series. And also we are using the function plot map, the function we defined before, to make a small map of the region we have selected. For example, in this example, we are plotting the time series of oxygen in this location near in the Japan Sea. And well, this is what the result, right? We get this is the time series of the system of the oxygen in this location. Well, this is just a first view of or it's just a first approach of the things you can, the kind of plots you can do with this kind of data. Obviously, from here there is a wide spectrum of things you can do, because this is just a visualization, but from here in advance you can start to make a computation over the data. So you get the data, you can do any calculus or any statistics you want, and after that you can visualize your results. So, well, this is the finishing of this tutorial. There is a final exercise. I think it's quite difficult, so take it easy. Just try the exercise, and it will be just afford this as the constructive way. So just play with it, and I think it's very interesting.
Thank you, Alvaro. Thank you for this introduction to the Jupyter notebook. So everyone, we've seen your comments. I know it is not easy to follow along. The idea is for you to just integrate these instructions, and for those of you who were not able to register for the Copernicus Marine Service or access the Jupyter Hub, you will be able to access these materials once you have access to the hub. They will still be there.